Dave Staublin here, and we're solving compound interest problems. And this next one, if you could imagine you're maybe a pro sports figure, basketball, football player, something like that, golfer, and that you have $1.4 million and you need $1.68 million in 2 years. What rate is required if you can find some instrument where it compounds monthly? Well, in this case, it's asking what rate, so we want to solve for R, so let's plug in all the other numbers. Well, you have 1.4 million, and you need 1.68 million. So that's your present value and your future value. 1 plus, we want to solve for R. We're compounding monthly, and we want it in 2 years. So that's what we got so far. So now we have to solve for R, and I'm seeing that we have 1.4 times this chunk of stuff. So let's divide both sides by 1.4. So that cancels, and 1.68 divided by 1.4 is 1.2 equals 1 plus R over 12 to the 24th power. Now, the tricky thing is, how are we going to get rid of this? Well, we could do log and bring it out in front, but then we have log of a variable, and there's no easy way to solve that. So I would propose instead that we do the following. You will remember that if you have something like 5, well, let's say x squared to the third power, that when you have power to a power, you multiply. And we're going to use that same concept. If we had 24 times 1 over 24, that would equal 1. And that's what we're going to do. We're going to raise both sides to the 1/24th power. And so 24 divided by 24 is 1, and anything to the 1 power is itself. And then we just have to do 1.2 to the 1/24th power, and it comes out 1.00763. So now, let's subtract 1 from both sides, and we would get 0.00763 is equal to R over 12. And if we want to solve for R, we can just cross multiply, and let's see, 0.00763 times 12 is 0.09156. 0.09156. So we are going to need 9.16% annual interest rate in order to see our 1.4 million grow into the 1.68. All right, that's it for this one.